All right, if you've ever felt like you're just drowning in data inside your code, you are in exactly the right place. Today, we're diving into one of the most essential tools for any programmer, the Java array. And the best way to think about it? It's like your very first data bookshelf.
You know, every programmer hits this wall. You start out with these nice single variables, kind of like individual boxes, but pretty soon you're just swimming in them. So how do you manage a whole bunch of similar information without losing your mind?
Let's make this real for a second. Picture this. You need to keep track of the test scores for 100 different students. Seriously, how would you even begin to handle that in your code?
Well, you could declare one variable for every single student, but yeah, as you can see, this is a total nightmare. It's messy, it's inefficient, and it's basically impossible to work with. There has to be a better way, right?
And of course there is. This is where we get to solve the problem by building that data bookshelf we were talking about. It's a really elegant way to bring some serious order to all that chaos.
That bookshelf has a name. It's an array. At its core, it's just a data structure that holds a collection of items, just like a shelf holds a bunch of books. It's the single container we need for all those student scores.
But this bookshelf of ours has two golden rules you absolutely have to follow. First, everything you put on it has to be the same type. You can't mix numbers and text, just like you wouldn't mix your textbooks with your potted plants. And second, once you build the bookshelf, its size is totally fixed. You can't just tack on extra shelves later. So, how do we actually build one? It's a simple two-step process. Step one is declaration. That's basically just naming your bookshelf. Then comes instantiation, where we use that new keyword to actually build the physical shelf and say exactly how many slots it's going to have.
But, we developers like to be efficient, so you can combine both of those steps into one clean line of code. This single line both names our bookshelf and builds it with 50 empty slots all ready for our data.
Okay, bookshelf is built. Now let's start putting our data, our books, onto the shelves. We do this using an index number inside those square brackets. That tells Java exactly which slot to put the data in. So, student score 0 gets the first score, student scores 1 gets the second, and so on.
And this brings us to probably the most crucial point, something every single programmer has to burn into their memory. Array indexing is zero-based. I'll say it again. The first shelf is always shelf 0. The second is 1. The third is 2. This is a fundamental rule in almost all of programming. You gotta know this.
Now, for a quick peek behind the curtain at what Java's doing. The variable student scores, which lives in a place called stack memory, doesn't actually hold all the scores. Nope, it's just a reference. Think of it like an address on a piece of paper that points to where the real array is stored over in heap memory. And notice the key detail. All the data is lined up side by side in one continuous block. That right there is the secret sauce to why arrays are so incredibly fast.
Okay, so what if one bookshelf isn't enough? What if you need to organize your data in more of a grid, like a spreadsheet or a game board? Well, we can actually scale this whole idea up and go from a single bookshelf to a whole library.
And we do that with a 2D array. The absolute best way to think about this is as an array of arrays. It's not just a single bookshelf anymore, it's more like a full cabinet, where each shelf is its own separate bookshelf. This structure is perfect for things like grids, tables, and even game boards. And here's a perfect example in action. To place an X on a tic-tac-toe board, you need two pieces of info, right? A row and a column. So in the code, gameBoard 01 tells Java to go to the first row, row 0, and the second column, column 1, and place an X right there.
So arrays seem pretty powerful, don't they? They bring order to chaos, they're super fast. But every hero has a weakness, an Achilles heel.
And for an array, its biggest weakness is that fixed size. This goes all the way back to our second golden rule. Once you build that 50-slot bookshelf, it is forever a 50-slot bookshelf. You can't change it, period.
And that leads to a very, very real problem. What happens if a 51st student joins your class? Suddenly, your 50-slot array just isn't big enough. What do you do?
Well, the solution is another awesome tool from Java's library, the ArrayList. Just think of it as a magical, stretchable bookshelf that automatically grows or shrinks whenever you add or remove books. Now, under the hood, it's actually using a regular array, but it handles all the messy work of creating a new, bigger one and copying everything over for you.
It gives you that awesome flexibility for when you just don't know how big your data is going to get.
Okay, let's wrap this all up with a quick toolkit, your personal cheat sheet to make sure these concepts really stick. First up, let's clear up a classic beginner's mistake. To get the size of an array, you use .length. It's a property, so no parentheses. But for a string, you use .length with the parentheses because it's a method. It's a tiny difference in syntax, but it's a super important one.
So let's nail down these core takeaways. 1. Indexing always starts at 0. 2. Length is a property, no parentheses. 3. Watch out for the array out of bounds exception. You will see this error. It's what happens when you try to access a slot that doesn't exist, like reaching for the 51st book on a 50-slot shelf. And finally, when you need that dynamic, flexible size, use an array list.
If you remember only one single thing from all of this, let it be this number: 0. It is where every single array begins, and it's the foundation for literally everything you're ever going to do with them.
You now have a seriously powerful tool for bringing structure to your data. So the only question left is, now that you know how to build the bookshelf, what amazing collections of data are you going to organize first?